Alrighty, ladies and gentlemen, today we're going to talk about transformations of our cubic function. So here we go. Alrighty, so our parent function for our cubic function is y equals x to the third. So now what we can do is we're going to graph it so we can see what it looks like. So we have an xy table. Now here is where we can actually, never mind, I'm losing my train of thought. So because it's being raised to the third power, we can put any value for x in that we want. So I'm going to go ahead and do like -2, -1, 0, 1, and 2. So if I substitute -2 into x to the third, that means I'm just doing -2 times -2 times -2, which would give us -8. -1 times -1 times -1 is a -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. And then 2 times 2 times 2 is 8 again. Alrighty, so let's graph these and see what it looks like. So if I go to -2, 8, 1, 2, 3, 4, 5, 6, 7. There we go. And then -1, 1. And then 0, 0. 1, 1, 2, 1, 2, 3, 4, 5, 6, 7. And here we go. Now, the cubic function, it kind of looks like you've got the straight line in the middle, but the cubic function, since it's got an exponent of a number, it is a polynomial function, and so it's got to be curvy. So what it looks like is we do this, we curve it here, and then we curve it here. And we have arrows going on both sides. So that's what it looks like. I know it's very easy to want to just draw a straight line there, but that's not what's going on. So this function, your domain is all real numbers, or -infinity to infinity, as well as your range. And there's really no number that we can't put in, and there isn't any number that we can't get out then as a result. So before we get into transformations, let me go ahead. We're going to look at Desmos real quick, just to kind of see what happens when we transform these, or this function. Okay, so a value, if I make it bigger than 1, it kind of looks like it's getting steeper a little bit quicker. It kind of looks like it's coming together a little bit closer to that y-axis. So when a is bigger than -1, or bigger than 1 rather, it's a vertical stretch. If I create it so we have like a decimal in here, like 0.4, it was skinnier and then it's getting a little bit wider. So we call this a vertical compression, or a vertical shrink. And if we make it negative, it reflects across the x-axis. So what was on the right, what was going up on the right is now going down on the right. What was going down on the left is now going up on the left. So both parts just flip-flopped. Alrighty, let's make this 1. H, when I move this slider to the right, it goes to the right. But remember, that means that we have an x minus an h value here. So x minus means we go to the right. If I put in a negative number for h and I simplify it, that changes that to an x plus. So x plus h means it goes to the left. K value goes up when it's positive, goes down when it's negative. Alrighty, and if you kind of like look here at that little point where it kind of changes direction, that point of inflection, that little point there in the middle is really, really close to what your opposite of h is plus your k. Or because again, when looking at your h value at x minus, you would see it as an x plus in your equation. So that's where that h and k will come from. That's where it is, right there. Alrighty. Okay, so let's talk transformations. Our a value again. So when it's negative, this means that we have a reflection across that x-axis. If a is bigger than 1, it's a vertical stretch. If a is in between 0 and 1, so again, that means numbers like 1/3, 2/3, things like that, or decimals like 0.3, 0.4. We call this a vertical compression, or vertical shrink. Your h, if we have an x plus h in those parentheses, that means we are going to the right, h units. We have an x minus h. That means we are going, oops, mixed that up. Let's go back. Eraser. X plus, I've got my x pluses and minuses mixed up. My bad. Okay, x plus h means we're actually going to the left. We're going opposite what we would normally think. X minus h means we are going to the right. And then that plus k means we are going up. And if we have a minus k, that means we are going down. Alrighty, so then we have some examples here. Alrighty, so we have an A value and we have an H value. We can tell that it's an H value, not a K value, because H values are inside the parentheses or inside any kind of grouping symbols or the function. So in this case, for this function, the grouping symbols are parentheses. So since 4 is on the inside, that is an H value. So that 2 is an A value. There's no negative, which means there's no reflection. But since 2 is bigger than 1, we're going to say, hey, this has a vertical stretch. X plus 4, since it's inside the parentheses, if I look back at my previous slide, we know that X plus means that we're going to the left. So we can say, hey, we're going to the left 4 units. Looking at the second example, we have a negative and then a plus 1. So that negative that's right in front of your x to the third is an A value, which means we have a reflection across the x-axis. Now, this plus 1 is a K value. If you notice the difference here between our first example and the second example, plus 4 was inside the parentheses, which made it an H value. This plus 1 is not inside the parentheses, so that makes it a K value. Since it's plus, we are going up 1 unit. So again, take a close look there at the difference between your x plus 4 raised to the third power versus your x to the third plus 1. So plus 1 is not it's not being cubed, so it's a K value. Alrighty, and so here we have a few more to go. So here we have that A value, it's a 1/3, which means we're going to have a vertical compression. X minus 3, so that minus 3 is inside the parentheses, which means it's an H value. So X minus means we are going to the right 3 units. And that plus 8 is on the outside of those parentheses, so it's a K value. So we're going up 8. And then last but not least, we have every single transformation going on that we can. So that minus sign means it's a negative A value, so that means it's a reflection across the x-axis. That 2 is bigger than 1, so it's a vertical stretch. X plus 6, it's inside that parentheses, which means it's a K value. So we are going to the left 6. And that plus 7's outside, so we are going up 7. So that is transformations of our cubic functions. So again, a lot of the same rules, just being applied to different functions. If you have any questions, please make sure you let me know.